So today's lesson is going to be on electron configuration. And electron configuration is just a better way of noting where the electrons are in an atom. So at first we started our unit and we learned how to draw Bohr models. But if you remember, I told you that, let me see if I can't focus this better. All right, there we go. So if you remember when we were drawing Bohr models, though, I told you Bohr models really don't work up after element number 20. And we talked a little bit about it having something to do with the third energy level. So let's look at electron configuration. This is a better way for us to figure out where the electrons are. So the electron configuration is simply the arrangement of electrons in an atom. All right. And what we've got is you're going to want to pull out your paper that looks like this, your periodic table. And I'm going to start teaching you with the way that I like the best. There's a couple of different ways to think about electron configuration. I like this way the best because the reality here is you will always be provided a periodic table. So if you know how to use the periodic table, then you'll be able to do electron configuration. All right. So here we go, electron configuration. What do we notice about this periodic table? This group is the S. This group is the P. This section is the D. And this section is the F. And I said group, let me use the word section so we don't get confused. The sections. So we have the S, the D, the P, and the F. Now, what does that mean? The S, the D, the P, and the F, these all have corresponding shapes. So what that simply says is a shape. And now I pulled this picture. Now let me place this picture up so we can see what I'm talking about when we're talking about shapes. So here's our shapes. The S has this circular shape. My P has this oblong shape. Here's the shape of the D, and here's the shape of the F. All right, so the S, the P, the D, and the F, when we talk about those letters, what we're talking about is the shape of that orbital where the electrons are found. So when we look at our group here, let's look at this element right here. This element, according to our periodic table, is boron. So let's do the electron configuration for boron. To do boron, the way we do our periodic table, we do 1s1, 1s2. This is 2s1, 2s2, and then over here we have 2p1. So what we've got here is an electron in the 1s1. There's an electron in the 1s2, an electron in the 2s1, the 2s2, and the 2p1. So this brings us into several different concepts. The first concept we're going to look at is our concept is called the off-ball principle. And this simply states that electrons are going to fill the lowest energy level first. For example, we are going to fill the 1s before we fill the 2s. And if you look here at what we just did for our boron, we did go 1s through the 1s before moving down to the 2s. So moving back to our electron configuration worksheet. Now this is the worksheet that is posted on to our website. We still need to define Hund's rule, but we're not going to define Hund's rule right now. So we're going to leave that section of our worksheet blank for now, and we're going to come back to it. Let's look at the electron configuration for phosphorus, and let's actually write that down. So phosphorus is number 15 on our periodic table. So phosphorus on our chart is going to be right here. So this is where we're headed. So when we read our periodic table, it's like a book. All right, page 1, we read left to right. Now, when you finish with page 1 in a book, what do? You flip the page and you go down to page 2. Page 2 has 2 paragraphs, the 2s paragraph and the 2p paragraph. When you go down from the 2p, after you finish page 2, what do? You flip to page 3. Page 3 has the 3s paragraph and the 3p paragraph. However, maybe the bell rings for you to go to another class, so you stop right here on your paragraph that you were reading, and that is phosphorus. So when we fill in our chart, we have 2s1, 2s2, 2p1. This is 2p2, 2p3, 2p4, 2p5, 2p6. So there's an electron at each one of these locations. Then we come down to page 3. This is our energy levels. All right, so energy level 3, 3s1, 3s2. Now we move over to the P, 3p1, 3p2, 3p3. So when we write our electron configuration, it's kind of be a lot to write each one of these individually. So what we're going to do is we're going to kind of shorten up a little bit. I went through the entire first energy level, so I'm going to simply write 1s2. By writing 1s2, this tells the reader that not only is there an electron in the 1s2, but there's also an electron in the 1s1. Now my next page, the energy level in this case, is the 2s. I go through the 1 to the 2s2. So I'm going to write 2s2. Then I'm going to come over to my next paragraph, 2p6. Now I finished with that energy level, and so I'm going to move to the next energy level, 3s2. And then I'm going to move to the 3p3. So notice when I write my electron configuration, I am following my off-ball principle. I'm filling the lowest energy level first. So the 1s has less energy than the 2s. The 2s has less energy than the 2p. So out of all of these, the highest energy is going to be the 3p. So that means the electrons in the 3p have more energy than any of the other electrons. So before we move on, let's take a moment and let's go through and let's fill in the rest of our chart. So we have 3p3, 3p4, 3p5, and 3p6. Once we finish 3p, we come down to the 4s. 4s1, 4s2. So I have electrons in the fourth energy level, but what do we notice when we hit our transition metals? We hit our transition metals and we jump from the 4s down to the d. The d is on the third energy level. And this is why Bohr models don't work past element number 20, because we have electrons on the 4s, but then they move back down to the 3d. The 3d actually has higher energy than the electrons in the 4s. So this would be 3d1, 3d2, 3d3, 3d4, 3d5, 3d6, 3d7, 3d8, 3d9, and 3d10. So what are we noticing here? Our S can hold a maximum of 2 electrons. Our P can hold a maximum of 6 electrons. And our D can hold a maximum of 10 electrons. When we come down to the F, if we were to count each one of these, we would end up at 4F14. So our F can hold a maximum of 14 electrons. So what I'm going to ask you to do, I'm going to ask you to pause this video. You are going to go through and you are going to finish filling in your chart. So example 3D10, now we come back to the 4P. So after the 3D10, we jump back up to the 4P. 4P1, 4P2, 4P3, 4P4, 4P5, and 4P6. So pause this video and finish filling in the rest of your chart appropriately. Then unpause the video to check your work. All right, here's what your entire chart filled in should look like. And so you can again pause the video here to check your work. And let's use this chart to do the next problem on our worksheet. And the next problem on our worksheet is oxygen. So oxygen is number 8 on the periodic table. So oxygen is going to be right here. Oxygen ends at the 2p4. So let's write our electron configuration for oxygen. Oxygen is 1s2, 2s2, 2p4. And let's do our final, well, let's talk a minute here. Before we do our final one, copper, let's talk. What does all of this mean? Let's get a different color here. The highest 2 energy levels in phosphorus is the 3s and the 3p. This is the third energy level. Now, if we were to count our valence electrons for phosphorus, and we've learned to count valence electrons, here's phosphorus, we count them 1, 2, skip the center, 3, 4, 5. Phosphorus has 5 valence electrons. 3 plus 2 is 5. So the 3s and the 3p are the valence electrons for phosphorus. Let's look at oxygen. Oxygen has 1, 2, 3, 4, 5, 6 valence electrons. What is the highest energy level in oxygen? And that is the second energy level. Both of these are in energy level 2. So 4 plus 2 is 6, which corresponds. All right, so we have 6 valence electrons. All right, let's do our final one, copper. All right, copper. Copper is on our periodic table, number 29. So copper is right here. Let me come to our filled-in chart completely. Right here, there's my copper, 3D9. So to write my electron configuration for copper, I have 1s2, 2s2, 2p6. I have 3s2, 3p6, and then I have 4s2, 3d9. We go 4s2, 3d9. Now, we have one more thing to look at. D9. The d orbital can hold a maximum of 10 electrons. Now, the reality here is electrons would love to be filled all the way. So if it's possible to get this D all the way filled, that's going to happen. So the D9 is going to undergo what we call an electron shift. One electron from the 4s will move into the 3d. So if I had 2 electrons and I take one away, what do I end up with? How many electrons? 2 minus 1 is 1. And if I have 9 electrons and I add 1, 9 plus 1 is 10. So 1 electron shifts from the S into the D. There is enough energy, it is energetically favorable enough for 1 electron to move. Now this will never happen in the D8 category because it requires too much energy to move 2 electrons. There's only energetically favorable enough for 1 electron to move. Electron shifts will also happen in the D4 because if we can get it half filled, a half filled D is second best. So in the D4 and the D9 only, we see this electron shift happening. So what I'd like for you to do is I'd like for you to go through and see about finishing our electron configuration, specifically where are the electrons in each one of those practice problems in each atom.